In this chapter, we mainly deal about graphing the six major trig functions, which are sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. So first let's see what is the domain and range for these six functions, and then we can go on to graph each of the functions and go into the details. So let's put the function here. Let's put the domain here and the range here. So let's start with the sine function. So sine theta, let's take it different. So say y is equal to sine theta or sine x. So what is the domain of for sine? Meaning what values can you put for theta? Any value. Theta can take any value from minus infinity to plus infinity, right? So the domain of r would be, or sine theta would be r, or all real. You can put all real numbers. And what is the range of sine theta? Range of sine theta is always between -1 and 1, including both of them. If you put any large value for theta, it will still be within -1 and +1. So the range of sine theta is -1 to 1, including both of the numbers. Now let's move to cos theta. If y equal to cos theta, what is the domain for theta? Again, cos theta can take any values because there is nothing in the denominator and nothing stopping you from taking any values for theta. That means the domain would be all real numbers for cos theta too. So it's all real. And what about the range? Just like sine theta, all the values of cos theta is between -1 and 1. So the range of the cos theta would be -1 to 1. Now let's take tangent theta. So tangent theta is actually defined by sine theta over cos theta. So here theta can take any values except that when the denominator is 0. So the denominator is cos theta. When is cos theta equal to 0? Let's see. So cos theta equal to 0 when theta is pi by 2 or 3 pi by 2 or 5 pi by 2 and so on, meaning it's a odd number of pi by 2, which is 2n plus 1 pi by 2, right? So tangent theta can take all values of theta except, so all values of theta, we can say all real, or let's put r, minus 2n plus 1 pi by 2, when, or except when theta is equal to 2n plus 1 pi by 2. So it can take these values in here. And what about the range of tangent theta? If you put all the values of theta in tangent, it can vary, it can result out at any range values, which is -infinity to +infinity. So let's take -infinity to +infinity. Remember, for the infinities you always put these brackets because it can't include the infinity. Infinity is undefined, there is no specific number. Now let's do cotangent theta. Cot theta is actually cos theta or sine theta, right? Cot theta is cos theta over sine theta. So the domain for cot theta, or theta, can take any values except when sine theta is 0. So when is sine theta equal to 0? Sine theta equal to 0 when theta equal to 0, pi, 2 pi, so on, right? So for cot theta, the domain should be all real numbers minus n pi, or where n is equal to 0, 1, 2, 3. So here n equal to 0, 1, 2, 3, so on. Same here, n equal to 0, 1, 2, 3, so on. So all real numbers except the multiples of pi, or 180. And what is the range of cotangent theta? It's just like tangent theta. It's minus infinity to plus infinity. Same brackets here. And then secant theta. What is the domain for secant theta? Secant theta is given by 1 over cos theta. So secant theta can take all values except when cosine theta is equal to 0. Just like tan theta, right? Where sine theta over cosine theta. So it cannot take any values pi by 2, 3 pi by 2, and so on, where cosine pi by 2 is 0, cosine 3 pi by 2 is 0. So secant theta can domain is all real values except 2n plus 1 pi by 2, just like tan theta. And then how about the range? Let's see. So the range of cos theta is between minus 1 and 1. If you think about it, if it's between minus 1 and 1, it's all fractions, right? Like 1 over something, 1 over 2, 1 over 3, 1 over 5, 1 over root 2. So 1 over something, either plus or minus. And we know that secant theta is 1 over cos theta. So if you do 1 over x, that is x, where x is greater than 1. So which means secant theta can never be a fraction. It's always greater than 1 or less than minus 1. If cosine theta is between minus 1 and 1, secant theta should be more than 1 or less than minus 1. So the range, or including 1, if this is 1 and minus 1, that should be included, right? So the range of secant theta would be minus infinity to minus 1, including minus 1, but not in minus infinity, union 1 till infinity. Now let's move to the next one, which is cosecant theta. Cosecant theta is given by 1 over sine theta. So what would be the range or domain of cosecant theta? When is sine theta equal to 0? It's just like cotangent theta, right? Where theta equal to 0, pi, 2 pi, so on. So that is n pi. So the domain for cosecant theta is r minus n pi. And what is the range of cosecant theta? Once again, the range of sine theta is minus 1 to plus 1. So the range of cosecant theta would be just outside that range, or greater than 1 and less than minus 1. So that would be just like the secant theta, which is minus infinity to minus 1 union 1 to infinity. So these domains and ranges are very useful when you plot the graph or explain the behavior of the sine functions and predict any behavior, something like that. So just go over this again later on.